Welcome to the lecture series of signal system. In the previous lecture, we started types of systems in which we have seen dynamic and static systems. Dynamic systems means the system which has memory, and if the system has memory, then it may take values of the input from the past, or it can take the values of the input, may take values of the input from future. So the system whose output depends on the previous or future value also of the input, that type of system is known as dynamic systems. And the system which does not have memory means a memoryless system whose output is depends only on the present value of the input is called static system. This is what we have seen in the previous lecture. In this lecture we will consider causal and non-causal systems. So the system is said to be causal or non-anticipative system which output at any instant of time depends only present or past value of the input. So the output of the system may depend on the past input also, but it can not take values of the input from future. That's why it is also known as a non-anticipative system. Means this system cannot anticipate, it cannot anticipate the future. And a system is non-causal if at any instant of time the value of the output of the system depends on the future value of the input. So such type of systems which output is dependent over future value of the input at any instant of time are known as non-causal systems. So the statement here is a system is said to be causal if output of the system at any instant of time depends only on the present and past values of the input but not on the future input. This is also called non-anticipative system. And it is written here, impulse response of the causal system is 0 for t is less than 0. Impulse response of the system will be 0 for the impulse input. The response of the system will be 0 for values of t less than 0, because impulse function exists only at t equal to 0. Impulse function exists only at t equal to 0, and for t not equal to 0 it is 0. That's why if we will see the response of the system before t equal to 0, means in this region it will be 0. That's what written here. The impulse response of the causal system is 0 for t is less than 0. It means we can write it as h of t is equal to 0 for t less than 0. The examples are examples for the causal system are yt is equal to xt minus 2 plus 2xt. In this example we will see for every value of t, the output of the system is dependent either over past value of the input or at the present value of the input. For example, if t equal to 0, for t equal to 0, yt is equal to x of minus 2 plus 2x of 0. This is the present value of the input and this is past value of the input. So the output is, because output is dependent over past value and present value of the input, that's why this system is a causal system. In the second example, where it is written yt is equal to tx of t. So because yt is given in the form t multiplied by x of t, so as output take values of variable t, in the same way the input takes values of the variable of the variable t. That means that yt and yt will always be dependent over present value of the input, because there is no operation with this variable, as it is written yt is equal to t multiplied by xt. It means that if I will put t equal to 0, then yt y0, then y0 will be equal to 0. If I will take t equal to 1, then it will be x1. If I will take t equal to minus 1, then y minus 1 is equal to x minus 1. It means that output is always dependent over the present value of the input. In the third example is same as the second one, which is yn is equal to n times xn. In the last example given here, yn is equal to yn is equal to x of n minus 2 plus x of n minus 1 plus x of n. It means that we can take some random values of n, so that y0 is equal to x of minus 2 plus x of minus 1 plus x of 0. It means that for the present value, the value of the output is dependent on the past values of input and present value of the input. The system is causal. If I will take, suppose n is equal to minus 1, then it will be y minus 1 is equal to x minus 1 minus 2, means x of minus 3 plus x of minus 2 plus x of minus 1. Because I am taking time instant minus 1 here, it means that x of minus 3 is past value for y of minus 1. X of minus 3 is past value, x of minus 2 is the past value, and x of minus 1 is the present value of the input for this output. So in all the cases I can take positive value of the n also. Suppose n is equal to plus 1, then it will be y of 1 is equal to x of minus 1 plus x of 0 plus x of 1. So in all the cases the value here is y1. X of minus 1 is the previous value for the output y1, x of 0 is the previous value for the output y1, and x1 is the present value for the output y1. It means that the output is dependent over the past value of the input and the present value of the input. So this system is also a causal system. The next is, a system is said to be non-causal if output of the system at any instant of time depends on the future input. The examples for the non-causal systems are given here. Yt is equal to x of t plus 2 plus x of t. It means that if I will put, suppose I am taking time instant t equal to 0, then y of 0 will be equal to x of 2 plus x of 0. Here the x2 for the output y0, x2 is the future input, x2 is the future input and x0 is the present input. It means that the output is dependent over future as well as present input, present value of the input. That's why, because output is dependent over future value of the input also, this is why the given system is a non-causal system. In the second example, where yt is written x square t plus t times x of t plus 1. Here, because of this term xt plus 1, the output of the system is dependent over the future value of the input. Suppose we are taking time instant t equal to 0, it means that here y of 0 will be equal to x square 0 plus 0. Or if we take the value, the time instant t equal to 1, then y of 1 will be equal to x square 1 plus x times x of 2. This x of 2 is future input for the output y of 1. It means that the output of the system at time instant t equal to 1 is dependent over the future value of the input. That's why this system is in the category of a non-causal system. The next example is yn is equal to xn plus x of 2n. In this case also, if we are taking n is equal to 1, then y1 will be equal to y, in this case y1 will be equal to x1 plus x2n means x of 2. Then for the output y of 1, the input x of 2 is the future value. The x2 is future for the y1. It means that this system is also a non-causal system. In the same way, the next example, because x of n plus 2 given here, if I will put n equal to 0, then y0 will be dependent over, then y0 will be dependent over 2x of 2. For y0, x2 is the future value of the input. It means that the given system is a non-causal system. Now here are we have seen some examples of causal and non-causal system to clarify the basic concept of what the anticipative system is, what the causal system is, and what the non-causal system is. We will consider some more examples in the next slide. As the first example is yt is equal to x square t plus x of t minus 4. Here we will take all the possible values of t for which the output, we can clarify whether the output is dependent on the previous value of the input, or the present value of the input, or the past value of the input. Suppose we are taking time instant t equal to 0. At t equal to 0, y0 will be equal to x square 0 plus x of minus 4. It means that at this instant t equal to 0, the output is dependent on the present and previous values of the input. Next, take t equal to any positive value, t equal to 1. In that case y1 will be equal to x square 1 plus x of minus 3. Minus 3 is the previous value for y1 and x square 1 is the present value for the y1. It means that the output does not depends on the future value of the input at time instant t equal to 1. Again, take a negative value of time. Suppose this is minus 1, then y of minus 1 will be equal to x square minus 1 plus x of minus 5. Here also, for the negative value of the t also, the output is dependent over present and previous value of the input, because x of minus 5 is the previous value of the input for the y minus 1. It means that the given system is an example of the causal system. The next one is yt is equal to x 2 minus t plus x t minus 4. Here take t equal to 0, then y of 0 will be equal to x of 2 plus x of minus 4. Here x of 2 is the future input for y of 0. x2 is the future input for y0. That's why we does not have to test the system for other values of the t. At t equal to 0, system shows that it is dependent over the future value of the input. That's why from here we can clearly state that the given system is a non-causal system. The next example is yt is equal to integration from minus infinite to 3t x tau d tau. Here suppose t equal to 1 is given here, then this integration will become y1 is equal to minus infinite to 3 x tau d tau. Suppose the value of this integration is something, suppose it is p tau. The integration is the function of tau, p tau. Then we will put the upper limit and lower limit to calculate the integration. Then we will get, this is p of 3 minus p of minus infinite. It means that at time instant t equal to 1, output y1 is dependent on p3, which is the future value of the input. p3 is the future value of the input. It means that the given system is a non-causal system. In the same way, in the fourth example, yt is given equal to x of t by 2. So if we are taking a value of t, suppose t is equal to 0.5, or we can say that it is 1 by 2. At t equal to 1 by 2, the y of 0.5 या y of 1 by 2 is equal to x of 1 by 4. It means that the 1 by 4, x of 1 by 4 is previous value for the y of 1 by 2, and at t equal to suppose t equal to 2, the y2 will be equal to x of 1. take another value of t. Suppose at t equal to minus 0.5, then y of minus 0.5 will be equal to x of minus 0.5 divided by 2, which will be equal to x of 1 by minus 1 by 4. Here minus 1 by 4 and y is at minus 1 by 2. Which one is greater? Y of minus 1 by 2, here we can see that y of minus 1 by 2 will be equal to x of minus 1 by 4. Obviously, this is minus 0.5 and this is minus 0.25. Minus 0.25 is greater than minus 0.5. It means that the value of the output is dependent over the future value of the input. For the point minus 0.5, minus 0.25 is the future value because minus 0.25 is greater than minus 0.5. It means that the output of the system at instant t equal to minus 1 by 2 is dependent on the future value of the input, and this system is in the category of a non-causal system. The next example is yn is equal to xn plus x of n minus 2. Put n equal to 0, it will become y0 is equal to x of 0 plus x of minus 2. This is present value of the input and this is previous or past value of the input. So at instant t n equal to 0, the system is a causal system. Consider another instant n equal to 1, then y1 will be equal to x of 1 plus x of minus 1. At n equal to 1 also, the system is causal because the output is dependent over present and previous value of the input only. And take another value of the n, negative value, n is equal to minus 1. Then y of minus 1 will become equal to x of minus 1 plus x of minus 3. So for y minus 1, x minus 1 is the present input and x minus 3 is the past input. It means that in this case also the output of the system is dependent over present and past value of the input only. Nowhere it is dependent on the future value of the input. That's why we can say that the given system is a causal system. The next example is yn is equal to x of 2n. From here we can clearly see that the given system is a non-causal system because if I will take n is equal to 1, then y1 will be equal to x of 2. Then y1 will be equal to x of 2. It means that for y1, x2 is the future value of the input. If the output of the system is dependent on the future value, it means that the system is a non-causal system. Y of sin xn, here the output of the system yn is given as sin of xn. Yn is equal to sin of xn. Xn is the input here. So If I will take y equal to 0, n equal to 0, then it will become y0 is equal to sine of x0. This x0 is the present value of input. This relation is simply can be shown as yn is equal to xn directly. Yn is equal to xn directly. So the given system is directly related to input as output of the system is directly related to input as yn is equal to xn. So for all possible values of n, the output will depend only on the present value of the input. From here it is shown clearly that at every instant of time the output will depend only on the present value of the input. That's why the given system is a causal system. In the next example, yn is equal to x of minus n. From here we can observe clearly that if I will take n is equal to minus 1, then y of minus 1 will become equal to x of 1. For y of minus 1, x1 is the future value of the input. Because 1 is greater than minus 1, it means that the x1 is the future value of the input for the output y of minus 1. It means that the given system is an example of a non-causal system. Next is this is yt is equal to x of sine 2t. Yt is equal to x of sine 2t. Here take some possible values of t. Suppose we are going to test the system at t equal to 0, then y of 0 will be equal to x of sine 2t, and t equal to 0 here, it means that x of sine 0, which is equal to x of 0. It means that at time t is equal to 0, the output of the system is dependent on the present value of the input. So at t equal to 0, the system shows behavior of a causal system. Then take a positive value of t. Suppose it is minus pi by 2. T is equal to minus pi by 2. Then y of minus pi by 2 will be equal to x of sine 2t, means 2 into minus pi by 2, which is equal to sine of minus pi, and sine of minus pi is equal to 0. Sine of minus pi by 2 is 0. It means that this is equal to x of 0. So x of minus pi by 2, y of minus pi by 2 is equal to x of 0. For minus pi by 2, the 0 is the future input. It means that the output of the system at instant minus pi by 2 is dependent on the future value of the input, and if at any instant of time the output of the system depends on the future value of the input, the system becomes non-causal. It means that the given question is an example of a non-causal system. So this is all for this lecture. In the subsequent lectures we will see remaining types of systems. Thank you.